Okay, so here we are, midterm review. If anyone has any questions, stop me and I'll answer them, but it's basic information. You'll want to try to remember the phrases that are in the written material. And I like I said, I've got it there for you to download if you want to, so you can go ahead and just read it. Okay, so the one that I have for you to download is a Word file that's 4 pages long, and it's in basic, sort of lists everything. So, goodness, I think we skipped a couple of pages. Yeah, okay, so binary digit is a bit, the smallest unit of computer memory. It's a 0 or a 1. It's on or off. And this is what we're talking about when we're talking about computer memory. You know, we're talking megabytes and gigabytes, but the most basic one is a bit. A byte is a group of 8 bits. Everything in computer language is connected or put together in sets of 8. So a byte is a group of 8 bits. A pixel is a picture element. One dot of light on your screen. The computer screen consists of a grid pattern of dots. So way back in the day, you could see the dots on your screen, but now we have very high resolution. But there are just millions of little dots next to each other, and they're organized in rows and columns. So everything is in a grid pattern. And that's what a picture element is. Aspect ratio. This is the proportion of the width to the height. So 3:2, 2:1, 4:3, 16:9. Classic films and television were 4:3. The current computer monitor and TV are somewhere in the middle. So you've got classic films 4:3. And then the Academy ratio, that's the size of big widescreen movies, is 1.37. So computer monitor and TV are 16:9. You find the aspect ratio by dividing the width by the height. So 16/9, if you divide that, it comes out to something between 1.37 and 4:3, which is 1.133, something like that. Okay, darn, this jumps ahead sometimes. Production terms, frames per second. The unit of frame rate, designated by the number of frames followed by P for progressive. Common frame rates include 29.97p, which is what we've been using, 29.97 FPS. It's called NTSC drop frame in some of the windows when you're entering information. It's necessary in early video to compensate for the addition of color by dropping off part of one of those pieces of information. So that's why it's 29.97. And that compensates for the addition of color. The frame rate we're using in this class is 29.97. 24p was the standard adopted for sound movies and 35mm sound film in the 20s and 30s. 25p is a video format that's used for compatibility with television frame rates, so you don't get those funny scan lines. And 30p is a progressive video format that's used a lot of places. So those are the common frame rates. Be able to recognize what is a common frame rate. So if you see a number that isn't this one of these, you'll know that it's wrong. And that way, when you're taking the test and you have to choose which one's a common frame rate, you'll know. So remember the common frame rates. Linked files. After Effects uses linked files. A lot of programs will use linked files. There's code that describes where an image is going to be located on your drive with a pointer to the physical location on the drive of the image file. So when you say physical location, I mean it's physical. It's actually there on a disk. You need to keep image files in the same folder on your disk or the file cannot be rendered. So if you move things after you've placed them in After Effects, you move it to a different folder, it won't be able to find it. So, you know, even if you're organizing on your desktop and you're saying, oh, this is too messy, I think I'll make folders. Well, if you've already used it in the After Effects file and you put it in a new folder, it won't be able to find it. So just remember that. If you find that you've got unlinked files, try to find where it is, remember what you've been doing, think about whether you reorganize some of the locations on the drive. Embedded files. Other programs may embed the image files, include the original code in the destination file when you import the file, and After Effects doesn't embed but links files that you import. Some programs give you the option of doing either. Some programs will only embed. When you embed the file, it makes that file much bigger because it has to put all the same information in it. And if you've got the original file on your drive and also the new one that has the embedded file, you end up using a lot of memory very quickly. The classic animators that we've talked about in class include Winsor McCay. He did the dinosaur. Walt Disney, that's Mickey Mouse, and Max and Dave Fleischer, they did Betty Boop, and they also invented rotoscoping. So Winsor McCay was an early groundbreaking animator who released Gertie the Dinosaur in 1913. And that inspired Disney and Fleischer to become animators. They saw this film and decided that's what they want to do with their lives. So he inspired them. He had a lot of influence on people at the time. Walt Disney, he's an early animator who became the most famous of his generation. He introduced Mickey Mouse, sound animation, and Technicolor cartoons, and the Silly Symphonies. Now, Max and Dave Fleischer, they're the animators of Betty Boop. In 1917, they invented rotoscoping, which is the method of tracing filmed or videotaped movements to create natural motion in an animation. We used rotoscoping to trace Edward Muybridge's image sequence of a buffalo running. You remember that. I would like to try to refer to things that we did in class so that it makes it easier for you to remember them when you're taking the test. And rotoscoping is the method of tracing frames from live footage, film, or video to create motion that appears both realistic and hand-drawn. It was invented and patented by Max Fleischer in 1917. In class, we rotoscoped a buffalo. I forgot to replace the word greyhound, but we rotoscoped the sequence that was created by Edward Muybridge. Production terms. Now, these are terms that we've been using in class, and remember how to use them the right way. So when you're going and talking to people in the industry, you can sound really smart. So a frame is a single image that is part of a scene, like a word in writing. A keyframe is a frame showing the beginning or the end of a move, or an important change in position or appearance. It's used as a guide for subsequent action, and it's used in storyboards to tell the story. And remember, the keyframes hold the information on the timeline. And when you get to the next keyframe, when there's been a change in position or a change in appearance, then the computer knows to take the two positions and to interpolate or figure out the number of frames between that will be needed to make that change over time. A storyboard is a visual outline of an animation or a movie that uses keyframes to describe that action. It contains notes about dialogue, camera moves, and editing. And then a scene is an action unbroken by any change to another visual, like a sentence. A sequence is a series of scenes expressing a single theme, like a paragraph. So this was the first tutorial files, right? Or the tutorial files we're doing now from project 2. And it has these scenes with the title, the fish tank, the aerating diver, the split cat in the end. So that's your scenes. And the fish tank and the aerating diver, you could argue, are a sequence. So it's a series of scenes, fish tank, aerating diver, because they're basically the same thing. They're in that same background. Raster graphics. Your image is composed of individual pixels on a two-dimensional grid. The master map is a grid filled with pixel dots to create the picture. In a raster image, when the object is magnified, the dots will become larger and are more apparent. You can tell where they begin and end. And the resolution or number of pixels per inch determines the clarity of detail of the image. So the more pixels per inch you have, the harder it is to see how many pixels there are, the harder it is to see them as individual pixels. You have them so many of them so close together that you can't tell. But when there's fewer of them, you can see the edges. You can tell how many pixels there are because they're just bigger. In vector graphics, mathematical formulas are used to describe the shapes in the file. The fonts are scaled without losing definition and appear the same at any resolution. So both of these images are of an A, and when they're at the same little size, they look the same. They look just the same resolution. But when you zoom in on the vector one and make it bigger, and you zoom in on the raster one and make it bigger, they become completely different. The vector one looks nice and sharp, but the raster one is all fuzzy because it has these edges that haven't been anti-aliased, or the edges have been fuzzed up so that they don't look jagged. If it hadn't been anti-aliased, everywhere that there was a diagonal would have little like saw marks on it, little jagged edges, because each of those pixels is square. So design theory. The rule of thirds was one of the design theories that we talked about, and this is the way that you divide your image plane into 9 equal zones by placing 2 vertical lines and 2 horizontal lines. And then you can line things up with the lines, and you can organize things in those squares. The space is organized to relate objects to the grid structure, and photography, film painting, and other fields will use this theory. Now here you can see Edward Hopper's image of the Cape Cod afternoon, and you can see that there's a grid structure to the way that the houses and the ground and the sky are laid out. There's a certain area where things occur that pretty much lines up with those areas of space. Gestalt principles. This is something that they invented back in the middle of the 20th century. And they were trying to figure out how you can organize information, and how do we understand information, and how can we communicate using that understanding. So they were relying on a lot of things to do with psychoanalysis and psychology. And it really is, basically, Gestalt is kind of partly psychology and partly communication. So in Gestalt, the parts of a visual image may be considered, analyzed, and evaluated as distinct components. And the whole of a visual image is different from and greater than the sum of its parts. So the way that the objects in an image work together makes it more important than just the pieces of information from each of those individual objects separated. When you put them together, they mean more. Figure and ground. The figure is a positive image and the ground is negative space or white space. And you can flip figure and ground, and that's what I have done in that picture of the two faces that is a vase also. So that's why I've got it with the two different colors flipped. Flipping figure ground is something that you can do in an image to make it more interesting. Equilibrium. Every psychological field tends towards order, balance, and maximum efficiency. So we like things to be balanced and even. We like structure. Isomorphic correspondence. The experiences of people, both physical and psychological, are recalled and triggered by specific visual images. So if something's happened to you that was traumatic while you were looking at a particular thing, then you will have an isomorphic correspondence. There's been lots of really wacky plays about that. But also, when you are conditioned to perceive something by society or the culture you live in, it has a certain meaning that everybody understands. So a stop sign that's red and octagonal, that means stop, and everyone knows that because we've been taught that. And everybody understands that. And if you see that image in a different context, you still see it as stop. And ice, like a snowflake, that's cold. So you immediately think of cold when you see a snowflake. And, you know, basically the stop signs and yield signs and caution signs, we've been told that's what they mean. We understand them. We are conditioned. And so isomorphic correspondence can be something that you've been taught, or it can be something that is a cultural or societal understanding that everybody's been taught, or that we all understand because we have the same experience. Or it can be something that's actually just something that you had an experience that will set off imagery. When you see it, will set off reactions. It's kind of like, well, you probably haven't read The Remembrance of Things Past, so we won't talk about that. Closure. We have a natural tendency to close gaps and complete an unfinished form. So if you see something that is a familiar shape with pieces missing, if there's enough of the familiar shape there, your mind has the rest of the shape in it. It will replace it for you. So we have a natural tendency to close gaps and complete an unfinished form. Proximity. Closer parts form groups by visually uniting. So when you have a bunch of objects in a space, the ones that are closer together will be one little group, and the ones that are further apart won't be part of the group. Continuation. Organization and perception leads the eye to continue along and beyond a straight line or curve, like arrows. So when there's some kind of a direction set up by some shapes, your eye just tends to follow that and go beyond it. So you can organize the space so that people's eyes are drawn to one particular part of the image that you want them to look at. And similarity. Identical visual images will be seen together in groups. Similar objects are defined by shape, size, color, and direction. And that's why you can see a group of cattle, Black Angus and Red Herefords are separate groups. Or if you're looking at a game that you're watching on TV, you can tell who's the good guys and who's the bad guys by whether they're wearing the light colored jerseys or the dark colored jerseys. So color theory, also we use color to organize information and to express some ideas. Warm colors, magenta, red, yellow, orange, come forward visually and dominate, but cooler colors like green, blue, and violet tend to recede. Colors can be warmed or cooled by mixing with other hues. Saturated colors will come forward, desaturated colors will recede. The comparison and the contrast will determine what the effect is. So if you look at this picture by John Singer Sargent of ships, you can see that the bluer colors tend to look like they're falling back. And then the redder colors, like the prow of the ship with that red brown, comes forward towards you. It's just this idea of space being set up by just color. Dominant versus subordinate. You can use placement, size, and relationships between objects to tell your audience what's important, how it's related to the space and to other objects, and what your animation will mean. Larger objects will be seen as more important. Objects in the foreground will have more importance than objects in the background. So dominance is determined by size, shape, color, value, depth, texture, density, saturation, orientation. So if you look at this picture by Elizitsky, Beat the Whites with the Red Wedge, which is from the Communist Revolution in Russia, you can see that the reds are piercing into the white, which is this big white space, which is actually kind of negative space in a sense. But you use closure to close it into this white circle. You've got this red wedge that's going into it. All these other red things are related to the red wedge. You've got this angle, you've got angles, diagonals set up. So there's this sense of imbalance, and that gets a lot of motion going on in there. You've got texture with some of the gray that's got sort of knobbly texture on it. You've got saturation. The red is very saturated, very strong. You've got orientation, the angle of that triangle going down, and then the opposite angle of the black line or black edge that's coming in the other direction. So all of these things will set up your design and organize the space so that it has a certain meaning, and people are drawn to the larger, redder, and more, I guess you would say, sharper shapes. Then colors, additive color system. The additive color system is the RGB color that we use for the computer screen. It's used in film, web, and video. Light is emitted from the source, so your screen is actually adding light. A wider gamut of color is available from additive color. The primaries are red, green, and blue. The secondaries are cyan, magenta, and yellow. And film and video file presets in Photoshop and Illustrator will use RGB color because that is the color that it needs to be for film and video. If you use some other color, it has to translate it. CMYK color is subtractive color. It's the print color system. This is the color system model used for print. Ink on the surface absorbs the light. The primaries are cyan, magenta, yellow, and black. Black is the K in CMYK. The secondaries are red, green, and blue, but they're not as bright as the red, green, and blue are in the additive color system. The file presets for print and illustration in Illustrator and Photoshop use CMYK colors. So make sure when you're working on something for an animation for a video that you're not using CMYK color. It has a much smaller gamut or colors available. The 12 principles of animation. We've been talking about these since the beginning, and some of them we've worked on in actual tutorials and in class on different things. Some of them are just things we've discussed a little bit. Anticipation is when your character is about to make a move and he pulls back to collect energy like a cat crouching before leaping. So it's this sense that something's about to happen. So we've got the little running guy there. And there's the list of different keyframes at the top. You can see we used to do this as a tutorial also. So staging, composing the stage to draw the attention of the viewer to the important details using placement, lighting, color, and gestalt principles of composition to arrange space. And here's the actual drawing I used to design the back wall of the stage for inside a kid's head, and then the actual brain painted on the stage that was used in the play. So remember, you want to make sure when you're designing something that you figure out where this viewer has to look, what's important, and then you make sure that the things that are in that area are larger and use more color and more vibrant and have better angles, and everything that's going on is going to draw your attention. And then anything that's subordinate to that has to be not as big, not as dark, not as bright, not as colorful, not as sharp. It has to fall back somehow in the mind of the viewer so it doesn't overshadow what you want them to look at. Straight ahead animation, that's what we were doing in that first set of tutorials that we did in project 1. So additive, you draw and duplicate the frame, add to the image, duplicate the frame over and over. Or subtractive, you draw, copy that frame, erase some, copy it, continue to erase and copy the frame until the image is gone. And then manual transform, draw and duplicate, stretch or skew or rotate, and just change the image a little bit each time. So those are straight ahead. Pose to pose, and this is from another tutorial that I used to do. The pose to pose, you have the main poses and then the in-betweens, and then you have the animation. I don't know why it only plays once. Whoop, let's go back one. It still doesn't go. Let's go. There we go. One more time. Okay. I think we missed one. Yes, here we go. Follow through an overlapping action. The motion of the character or object is shown as layers of fluid motion occurring at the same time, but with slightly different timing and placement, like swinging the arms while the legs are walking, not the exact motion, but during the same sequence. When the main image stops moving, the parts may continue and then return, like the hair on the head of a character as it stops running. And here you can see that as the horse is galloping, the lei around the horse's neck is bouncing up and down, and the tail on the horse is flopping a little bit, and Bugs Bunny's braids bouncing up and down. So these are all follow through an overlapping action. Ease in and ease out. You ease into the station. It slows down until it comes to a stop. Or you ease out from the station. It starts slow and speeds up. So you ease in by I got that backwards in there. Okay, so you ease in and you slow down as you're coming to a stop. You ease out and you speed up as you start going. So ease in and ease out was called by Ollie Johnson and Frank Thomas slow in and slow out. It's the same idea. Arcs. Animals and people usually move in curved paths. Straight line motion looks mechanical and unrealistic. So this is a walk cycle from Preston Blair's book, Cartoon Animation. And you can see that he drew the arc over the head of the character to determine where the head was going to go so that he could get the steps right and the actual arc of the motion right. Secondary action, eyes blinking and arms swinging and feet tapping. Living creatures move their bodies in different directions all at once. So use simultaneous actions to make it look realistic. So secondary action looks a lot like the overlapping action. It's hard to tell which one is what usually, but it's just the idea that things don't just all move in one piece. You have all kinds of different motion happening at the same time. Timing. The real world has realistic timing. Things can only happen at a certain speed. To make the animations more realistic, use your timeline to organize the motions and make it seem believable. So if something's happening too quickly or too slowly, it won't feel right. And this is, as I said, one thing that's very true. Every year somebody does a gun shooting and they try to show a bullet coming out of the barrel of the gun. And the bullet comes out and it takes an entire 5 seconds to go from one side of the frame to the other. And that doesn't make any sense. So you've got to remember there's certain timing that things do. So you have to make it go faster than that. So exaggeration, used skillfully and in careful doses, exaggeration can add humor, liveliness, and improve the impact of your message, as well as draw the attention of the viewer. So you can see that this is the old man in the mountain in Betty Boop, and the old man is extremely exaggerated. Betty Boop's even exaggerated. And this was all done for the purposes of adding humor and liveliness and fun to it. So you can exaggerate things like somebody's big toe or their nose, just if you want them to be funny. And her head is so huge. Really, her head is really huge. That woman would fall over. Solid drawing is an important idea. Good understanding of visual principles like how we understand two-dimensional and three-dimensional space and how to show mass, weight, and materials in a convincing way. In other words, being a good artist. And here's a figure of a woman shown in motion by Albrecht Dürer. You can see that he has figured out all of the distances and widths and angles and how this woman is put together. Then there's also appeal, giving the character personality the appearance of emotional depth. Kittens have appeal, but so do alligators, creating an emotional reaction to a perceived personality, positive or negative. So you want to have the characters that you have invented, you want them to evoke emotion in people. And a lot of things that are not characters can have appeal as well. You want to make whatever it is that you are using for your animation, you want to get people to have feelings about it. Now, one of the things that we learned about was persistence of vision. I told you about that. The eye sees images in sequence that change quickly, and those images persist on your retina of your eye until they're replaced by the next image, and they are interpreted by the brain as smooth motion. This concept is the basis for movies, video animation, etc. One of the earliest types of animation that they invented was a phenakistoscope, which is also called a phantoscope. And this is what it looked like. It was a round disc with images painted around the edge. And then there were slots that you would look through. And there was a pinhole in the middle that you could stick a pin through. And then you would spin this and have it face towards a mirror. And you would look through the slots at the mirror and you could see these people dancing. So it was interesting, but it's one of the things that helped people understand how we see. That was a fade. So we're going to talk about transitions here. That was a fade or a crossfade. The gradual appearance or disappearance of a scene to black. Fades separate major sequences of action and suggest a lapse of time or a change of location. The length of the fade determines the dramatic effect. And a crossfade is when you have one scene fading out and another scene fading in and they overlap. This was a wipe. The Venetian blinds is a type of wipe. In a wipe, the current scene is displaced by the following scene with a distinct edge between. In this case, the shape of the blinds is a set of parallel bars which grow or shrink to reveal the next scene. And that was a diagonal wipe. A horizontal, vertical, or diagonal wipe displaces one scene with another with a distinct edge between. In this case, the first scene moves from the right to reveal the next scene, and the edge is feathered to create a smooth transition. And then an iris wipe or a circle wipe. The iris or circle wipe displaces the following scene with a round or oval shape and grows or shrinks to reveal the next scene. Now, some file formats and extensions that we've been using and that you'll run into. The PSD, that's a Photoshop file. It's proprietary. That means that they have a copyright on it. You cannot write your own PSD file. You have to use Photoshop's PSD format. It has to be made with their product. So it's a proprietary file format for Photoshop. It's raster with vector capabilities. The text layers in Photoshop files can be converted into editable text in After Effects. So that's the important thing for what we've been doing is we have been using Photoshop so we can convert to editable text in After Effects. AI is the proprietary file format for Adobe Illustrator. Once more, it has been copyrighted, so you can't make your own. Vector-based images and graphics. Vector art can be converted to After Effects shape layers, and Illustrator layers can be continuously rasterized for sharper resolution. AEP, that's the proprietary file format for Adobe After Effects. It's a project file. After Effects is visual effects and compositing application used for motion graphics and film production. An MP4, which is an MPEG-4 Part 14, is what the more serious name is. A digital media format based on QuickTime for compressed video files. The MP3 is an MPEG-1 or MPEG-2 audio layer 3, a compressed audio coding format for digital audio. The AIFF, which is another one of the file formats that's available to save from Audition, and that you also will run across AIF files when you're downloading from the web sometimes. Audio interchange file format. It's a digital audio file format developed by Apple Incorporated in 1988. And the WAV is a waveform audio file format, an audio file format standard developed for storing audio on PCs, a Windows and IBM audio file format. After Effects import options. When you import as footage, the file is imported without layers. Audio files are considered footage. Composition. When Photoshop or Illustrator files are imported as composition, all the layers are available to be edited separately. And composition retain layer sizes. When PSD or AI files are imported with retained layer sizes, the anchor points are placed relative to the center of the object on each layer instead of the entire file boundaries. Now, in the past few weeks, I have found that the top layer has that truth to it, but layers underneath the top layer will have the center in the middle of the file boundary. I don't know why. It's just started happening recently. Maybe they'll fix it. Keyboard shortcuts. Some useful keyboard shortcuts that we have used in class. U, when you press U, it reveals all the keyframes that have been created for the current layer, or if no layer is selected, will reveal all of the keyframes for the entire comp. LL, when you have a sound layer selected, LL reveals the audio waveform for the sound layer. V, when you have any tool that is not the selection tool and you press V, it will give you the selection tool. So it just changes the tool to the selection tool. P, when you have a layer selected, it reveals position transforms for the current layer. Or if you have no layer selected, it will reveal position transforms for all of the layers in the comp. And similarly, T reveals opacity transforms. So opacity, T for opacity. R reveals the rotation transforms for the current layer. S reveals scale transforms for the current layer. W will select the rotation tool when you have another tool selected. Y will select the anchor point or pan behind tool. Now, all of these tools shortcuts, don't use them if you've been typing with the text tool. If you've been typing with the text tool, go to the top of the window and select the tool from the toolbar. Because if you use any of the shortcuts, it will simply add a letter to the text you've been working on, and you don't want that. Now the open bracket will select the move point of the current layer. So it moves the move point, the endpoint, excuse me. It moves the endpoint of the selected layer to the current CTI position. And then the close bracket moves the up point of the selected layer to the current CTI position. In any program that you're using, Command Z will undo the previous action. Command A will select all. Now, if you have been working on a paragraph, it will select all of the paragraph. If you've been working on, I don't know, it selects all on the screen, but it depends on the situation, all of what. So Command A selects all. Command Z undoes the previous action. Command A selects all. Command S saves your file. I'm having a coughing thing starting here. And that is the end.